Hi, I'm Sue Stockdale and welcome to episode 104 of the Access to Inspiration podcast, where you can be inspired by people who may be unlike you. We hope that by listening to their stories, you can transcend your day-to-day challenges, gain new perspectives, and be inspired to try new things. You'll find the transcription for this and all our other episodes at accesstoinspiration.org. For this series on climate solutions, we have partnered with the Royal Scottish Geographical Society, a dynamic educational charity working across Scotland and beyond to promote geographical understanding and joined-up thinking. The RSGS has developed several exciting projects to enhance your understanding about climate science. So keep listening and I'll tell you more about that later. To become a member of the RSGS, go to rsgs.org. Today I'm talking to Roisin Hyde, who's a chartered architect specialising in sustainable design and has a PhD in Parametric Design, Novel Materials and Digital Fabrication. Roisin spent 5 years developing, testing and validating a sustainable model for the 3D printing of low-carbon concrete components, and her business recently has been nominated for the EarthShot prize. Welcome to the podcast, Roisin.
Thank you so much, Sue.
Now that sounds like a very intriguing nomination and prestigious one at that. Tell us more about what that actually means.
Well, the EarthShot Prize, I think it was founded 2 years ago. And so it's to help support startup companies who are working in the area of either habitat restoration or to protect habitats. So in my case, it was the World Wildlife Foundation who nominated my company Nomad. By producing concrete using byproduct and waste materials instead of virgin resources, we can protect, I think 1/3 of global resources goes into the production of concrete. So mining and open cast quarrying and the extraction of limestone and aggregate materials. So if we start to make concrete in more sustainable, circular economic way, we get to protect those habitats. I think the World Wildlife Foundation recognized that this was a good idea for their interests. So they nominated me, and we'll find out, I think in September, there'll be a shortlist announced, and then those companies are supported in their work and mentored, and there's like an accelerator program and just an opportunity to grow your ideas and your business, scale up.
It sounds fantastic, and we wish you well in that as it progresses, Roisin. Now you've opened up a whole can of worms there, getting us to think about concrete and the impact that it can have if it is created differently, and threatens no doubt to disrupt that industry completely. So how did you get involved in this in the first place?
I was a chartered architect for 15 years, specialising in sustainable design and energy efficient buildings. And the more the science evolved and we began to recognise the impact of the changes that we were making, I was concerned that they weren't enough. And I was also frustrated by the lack of high performance sustainable construction materials and components. So a lot of the materials that you build buildings with that are sustainable are very bad for the environment, like these polyisocyanurate insulation panels and steel cladding and aluminium cladding, and the materials that were sustainable were very low performance. So there are nice, lovely things like hempcrete and hay bales and sheep's wool and all those lovely things. But first of all, they're super expensive. They can't really be used for buildings more than 1 or 2 stories high, and they don't have the lifespan. They start to fail. Well, things like the sheep's wool insulation just doesn't last. So I went back to university to do a PhD, and my objective was to produce something that was high performance and sustainable, something that was better than conventional construction materials and also gave the thermal performance to conserve the energy that buildings consume, but that was more sustainable. So high performance, low carbon, which there wasn't a lot of.
So you were a Fulbright visiting researcher in North Carolina, Roisin. What did that involve?
I worked with a professor, Brett Tempest, in the University of North Carolina, and he was actually the first person or the first team working with the architects and engineers in the university to create a geopolymer concrete cladding panel as part of the solar decathlon. So he had used a mix with fly ash, which is a byproduct of the coal industry. And obviously we're trying to phase that out, and there will be less and less of it, hopefully. So I had started to look at materials from a circular economic model of recycling steel. Charlotte in North Carolina actually has an amazing model of recycling a lot of their waste materials and some products within the city, and they take all of their scrap metal and they recycle it 10 miles outside the city, and they turn it into steel beams, which are then used to build all the new buildings that are being built. But the byproduct from that process is a slag material. So I visited North Carolina for 6 months, and I worked with that slag material with Professor Tempest to produce a high performance concrete material made with their local waste. I also got to travel to California and do some work with Elon Musk's boring company. They're digging tunnels under Los Angeles and Las Vegas. I got to visit both of those sites and work with the guys and meet lots of engineers through the American Society of Civil Engineers and to present my work at the American Concrete Institute annual convention. So yeah, it was an incredible experience. Fulbright started after the Second World War as a way of connecting all the researchers and academic around the world to work on share knowledge and share experience and progress certain agendas like sustainability. So they supported me in working with someone in my area to work with his design and my material and just take it that step further. So it was an amazing opportunity.
It does sound brilliant. And why do you think that challenge or that problem hasn't been tackled prior to you looking at it, Roisin?
Oh, well, I wouldn't say I'm the first there. Fortunately, that's the one thing you learn is modesty when you do a PhD. You realize that your contribution is just an illustration of the field, and then it zooms in and zooms in and zooms in, and your contribution is a tiny pinprick pushing the boundary. And you also connect with this global community of researchers. I learned within 6 months that there are tens of thousands of people active in this area, which is also very reassuring because when we worry about the future of the planet, sometimes I think people who are maybe not part of this community think no one's doing anything about it, whereas the reality is there are possibly even hundreds of thousands of brilliant, dedicated, hardworking, visionary people that do nothing but. So I suppose you connect in with that community and it's a team. So you're all looking at different parts of the work. The whole thing about a PhD is that it should be original. So you look at an area and then you look at a part of it that nobody's working in and then you work in that area. I was an architect working with material science and engineering. I was bringing my knowledge of architecture and working on building sites to the development of materials. So for most of the people in that field might have been chemical engineers or material scientists from engineering backgrounds. I was coming at it as an architect who was almost like the customer. I was pulling the technology, whereas maybe they're sometimes pushing it and they don't know if it has an application. I was looking for materials to solve a problem that I had. So just coming at it from a different perspective, really.
And it's interesting you say that. One of the previous guests in this series, of course, it's on climate solutions, has been talking about the importance of looking at something from a systemic perspective so that activities aren't just working in isolation. And that's what I'm hearing you say here.
Yes, non-siloed thinking. I think that's really, really important, that you have a lot of amazing work going on in parallel and people aren't making connections between those. I suppose as an architect, you're used to working across a team, managing engineers, contractors, specialists, subcontractors, other designers, a whole range of quantity surveyors, a range of skills. So your instinct is always to look at the resources available and then make the project using those resources. So I had the same approach. I spent the first 2 or 3 months going around to every lab in physics, chemical engineering, geology, food science, the lot. I wanted to see all the toys that we had. And it was like almost 20 years since I'd previously been in university, and they've become a lot better equipped and things that only maybe 1 or 2 universities on the planet had then. Now most universities have them. So these incredible material characterization labs where you have scanning electron microscopes and X-ray spectroscopy and XRD and XRF and all these, amazing things. So you can look at materials on a molecular level. And as an architect, I think I had a different perspective and maybe different ideas. And that cross-fertilization is a synergy there where 1 + 1 is 10 because you're bringing people from different backgrounds together.
So given that looking at things from a holistic perspective is an important skill that you were already bringing in from your work as an architect to the research that you were doing, what did you then discover as a result of the research?
That there was, I suppose, a lot of different approaches to the problem. It's like the technology is already 20 years ahead of the industry. It's like with mobile phones and all those technologies, computers and miniaturization. It's been around for 20, 30 years, but it doesn't necessarily reach the market because it's got to go through stages. So by going back into a research environment, I was exposed to all the stuff that was coming down the pipeline, and I was able to travel and meet the people doing the research and then see what might be suitable for my application applications. So it's a bit like looking into the future. I was just thinking about it today. When you're involved in this area, at the end of this PhD journey, I can actually very definitively predict what the cities and built environment will be like in 20 or 30 years, because I've met all the people who are doing the work and I see the things that are picking up momentum, but I also see the path that they have to go through to be ready for the market. So there's all sorts of exciting things coming down the line, and most of it is very good.
And you also had a TED Talk a number of years ago, and that was about geopolymer, am I right?
Yes, so the concrete material that I focused in on for my research. So a lot of concrete materials that are made with supplementary cementitious materials like non-Portland cement materials are weaker than conventional concrete, but geopolymer is actually an inorganic polymer, so it's not the same. Basically, concrete is a material that was dried really, really fast, limestone, and the CO2 is driven off, and then you're adding water again, and it's hydrating, and this is crystalline reaction, and you get this precipitate, and you have this binder formed in that process, whereas a geopolymer is actually like a long chain polymer, and the process is a different reaction where you get all sorts of different molecules formed, and they're all floating around, and then they start to connect together, and the better the reaction, the longer the polymers. So polymers give you very strong materials, flexible, durable. They're very inert, so the material ends up being less reactive chemically, so it can be used in extreme conditions. Also, water isn't part of the material, so it means that when you heat this material up, it won't crack, or if you cool it down, it won't expand and crack. So geopolymer can be used to make concrete, which is better. It's stronger, more durable, and has far less CO2 than conventional concrete. So geopolymer, it's really a super material like carbon fiber or carbon nanotubes or graphene, or it's a pretty incredible material. And it's probably been around for thousands of years. The Romans likely made it without knowing what it was. They just knew by mixing a bit of pozzolan and mixing something else and putting it into saltwater environment that they got super, super strong concrete. I mean, nowadays we have the technology to look at it under microscopes and bombard it with X-rays and analyze the nanostructures of it, but they were doing it 2,000 years ago and, doing a pretty good job as well.
Given our podcast series title is Climate Solutions, and you're describing this as a solution, what's the reason it hasn't been used to date?
There are a number, but I would say at the beginning of my research journey, I was more thinking the people in the industry don't want, because this is going to disrupt and take away from them. Now I realize that there's just a journey where the things have to go through for safety and testing. And I mean, there is a little bit of maybe resistance from the industry, because when you think of the model like by which a company would make concrete, a lot of them have invested in quarries, concrete and cement plants where they have big giant kilns that cost millions of pounds. And so they've got all that equipment in. It doesn't make its money back in a year. They need 20, 30 years to get their money back on that. And then you're coming along saying, let's do it all differently. Let's not use limestone, not use your kilns to calcine the material. Let's do it differently. So you want to be really sure before you make that move and encourage industry to make that move that what you're proposing is viable. So there's a lot of research going on in this area. As I said, people all over the planet are looking at the types of applications, and there's, I suppose, an approach has evolved that this should be targeted at high performance applications. So you wouldn't use geopolymer in every single application for concrete. Other types of concrete, supplementary concrete materials and low carbon materials might be more suitable, say, for foundations or something. Whereas if something has to be thin and strong and durable, like the facade of a building that I was doing as part of my PhD, then you would use a geopolymer. And then also since then I've started 3D printing with it, because I realized that 3D printing material, you wanted it to be as thin as possible, as strong as possible, rapid setting, and an awful lot of the characteristics occur naturally with geopolymers. So yeah, it's just the risk is huge for the construction industry. If something fails, if a bridge fails, if a building fails, that's a huge risk to life for the company. So you don't take risks in construction. Things need to be tried and tested and proven to be safe before the industry will accept them. But there is definitely change. Even over the 5 years that I've been working in this area, there's huge change. There's much more openness to experiment and to look at alternatives. I think it's carrot and stick. There's big taxes coming in for producing carbon. There's deadlines of reducing their emissions by 30%. And concrete is the easiest, fastest way to do that. Even if you didn't look at anything else on the building, like no windmills or solar panels or anything else, if you just looked at a more sustainable concrete material for foundations and columns and floor slabs, you would deliver that 30% saving. So it's a big strategy to deliver on our 2050 net zero targets. And people are recognizing that. And there's growing momentum in making those changes.
It's sounding really exciting as you're describing it, Roisin. And I'm also getting the sense of the breadth of knowledge that you're bringing to the work that you're doing. So I'm wondering these days, how do you describe what it is that you do? So I'm not imagining that you're still describing yourself specifically as an architect.
No, I know. I'm not entirely sure. Every time I have to go to my LinkedIn page, I change the description and update it. As I said, I do spend an awful lot of my time cleaning concrete hoses from my concrete printer. So that would describe a good 50% of my daily activity some weeks. So I suppose advocacy has become a big part of my role. Education, I feel, when you're invested in, as you are as a PhD researcher, and also through my Fulbright, there's a lot of people giving you access to a lot of resources. You're getting a lot of training in a lot of skills, and that's a privilege, and it's one that you should share every opportunity you get. I do a lot more mentoring now with students of all ages from 5 up. I do a lot more outreach work. If a company's interested in trying to decarbonize, I go in and talk to groups of people like from the Mineral Products Association, from the Concrete Society. So I do a lot more public speaking around the area to help people understand the strategies and pathways and technology that they can use. So definitely advocacy has become a big part of my work. And I still suppose at the core of it, architects do get involved in all sorts of interesting things. So it's always been a broad range of projects. And so for me, at my core, I'm still an architect, but I've just expanded my knowledge and moved into education and advocacy as well as architecture.
If this episode is inspiring you to find out more about climate change, then the RSGS Climate Solutions course can give you a greater understanding in a quick and simple way. It's been developed by leaders and experts in climate change from the Royal Scottish Geographical Society, the University of Strathclyde Business School and the Edinburgh Climate Change Institute, and it's endorsed by the Institute of Directors. In just 2 hours, you can learn about practical solutions that you can implement immediately to help tackle climate change, direct from world-leading experts. Head on over to climatesolutionsnetwork.com to find out more. Now back to the podcast. So how do you measure your own success, given that you have got such a broad range of activities that you can get involved in?
Impact, I think. So it was why I chose concrete as the focus for my research, because I became increasingly aware. I think when you become a parent as well, it heightens your sensitivity to risk and danger. And so even though right from my undergraduate days, I always specialized in eco-friendly, sustainable buildings and always used solar panels and heat pumps and everything else, I expected we'd make more progress. I suppose I'm probably 20 years in the business, and I can see over that time frame how much or how little has happened. So in the last 5 years, I became concerned about how little impact we were having, and that the actions, I remember once doing the whole facade of a building in solar panels and looking at the electricity we got from it and just going, this is not enough. Yes, it's great, but given the pace of global warming and how close we're getting to the tipping point and a point of no return, I just felt that I had to focus on strategy that would give us the biggest return and impact, and that is decarbonizing concrete. And I feel the more people that I can share this knowledge with, that's how I measure my success. So, I mean, I get to work with Balfour Beatty, who are the UK's largest construction company, and FP McCann, who are the UK's largest precast concrete manufacturers. So I'm working with them day to day and feeding into, their business model and future plans to decarbonize. So that's my success metric, really, is the potential for impact. Every time I get the chance to talk to a group of engineers, architects, students, quantity surveyors, people who are just generally interested in decarbonising construction, I'm sharing strategies and knowledge and solutions with them. And I hope people come back then and they go, okay, we want to do a project. Can you tell us how we do this? Who should we talk to? How we go about it? And I can help to provide that information and facilitate this transition that we all need to make in the construction industry.
Well, it's lucky that our podcast, of course, is called Access to Inspiration, because I can see the important, inspiring role that you're playing in the whole journey to decarbonisation of concrete, as you're describing it there.
Hope so, yes. Especially for the younger generation. I sometimes fear that COVID really knocked them and they seem to be a little bit disempowered and disenfranchised at the moment. So I think it's really important to connect with them and say, this is your planet, ultimately. We'll be gone. All we can do is point you in the right direction. People alive now are the last generation that can do anything about climate change. And even just to communicate that one fact to them, this is up to you. I'm doing what I can do, but you need to start doing this too. And I'll be gone and you'll be here, your children. And so empowering the next generation is very important to me, that they feel they know what to do and they know how to do it, and they feel empowered that they can actually make the actions. And it's very inspiring when you see a lot of the activists and what they're doing.
Jojo Mehta, in an earlier episode, talked about carrot and stick approach. So the importance of inspiration as well as having consequence to one's action. I'm wondering, what do you think, as you look into the industry and the amount of interest or resistance that you're experiencing, which do you think is going to yield a better result? More carrot or more stick?
Gosh, I'd like to think it would be maybe more carrot, but we don't have a lot of carrots at the moment, do we? Post-pandemic, carrots are thin on the ground. So maybe there's a third force in action there as well, which is just our sense of humanity and our sense of leaving the planet a better place than when we found it. I was just thinking today about the amazing support and collaboration that I get from a lot of Scottish companies. And I was thinking about this bond that I feel particularly with Scotland. And I think there's a shared heritage. I don't know if it's like the whole farming and fishing background, that we all support each other as a community. And so I think possibly you can also maybe strengthen those community and social bonds. So that's the environment. So maybe we can enrich the environment, like making it an oxygen-rich environment or a fertilizer-rich environment where the carrots will thrive. But I think we need to do that work on society to make people work together as a team and support each other and empower each other. And then within that, we need businesses that are invested financially and technically and in terms of their skills in a certain model and now need to make changes, need to be supported. So my experience is not that a lot of big cement and concrete companies are determined to ignore this. It's just that it's a huge financial investment for them to change their business model. And also they're not sure what to do. They're not sure, is this technology going to deliver? We're doing something that's been done for 2,000 years. It's been working perfectly well. Like if we change to one of these other technologies, are they going to be viable long term? So it's not that they're not willing to do it. It's just that they need some security, because if they take that big risk, who's going to support them if they fail? I think they need guidance as much as the stick then is carbon taxes and things. I think it should be proportional. The stick should be proportional to the carrot, because you can't poke people too much unless you put in place an environment and support for them to succeed. And I don't think particularly they feel at the moment that support is in place, because whenever I do talks about my work for, say, the Mineral Products Association, hundreds of people show up and they're really interested and they reach out to me afterwards and they ask more questions on how they can do things. It's not that the appetite isn't there for it. It's just that they want to be sure and they want some support in place for making these changes and basically having to dump a lot of the technology they've been using, like kilns for calcining materials. And so it's both on the external force of society to support and recognize how complicated it is to change. I often feel it's like when the Titanic was going for the iceberg, it has to be a slow, steady pulling away from it. We can't do anything sudden, because they did the sudden thing and then they ripped the whole side of it out. It's not a rapid action, but it needs to be in the right direction. We need to gradually pull away from the current model and move ourselves to a more sustainable economy and practice.
When you were young, Roisin, was this the career that you envisaged that you would have, or has it evolved over time?
I always wanted to be an astronaut, so that lasted till I was about 10 or 12, and then just started to seem a lot less viable being from Ireland and ending up on the moon. But I still dream. I liked making things and I liked projects and constructing, and like summer times I was always building tree houses and teepees. And so it just, when it came to university, it seemed like a natural thing, something where you could make and do. It was also a bit serious because it was buildings and not just little kind of structures in the back garden for you and your buddies. So yeah, I think I always had an interest in making things and building things and spaces. And I think it's what motivates you, because architecture is a pretty full-on 7 years to qualify. So it's not something kind of take on light, and you don't tend to finish if you're not really committed and you're really in the right. I think there's probably like a 50% dropout rate from people who start in first year. So yeah, there's very few architects who wind up with a degree who are not passionate about what they do.
Well, you reminded me of one of our previous episodes. We did have an astronaut on the podcast, and he was former research manager of the International Space Station. And it was because of his telescope that he had designed that he went into space in the space shuttle. So maybe there is possibility there for you in the future.
I work with companies involved in this, and the 3D concrete printing, I use basalt for like one of the materials that I'm using. And I actually had a project with the European Space Agency that reached the very last few, but it wasn't financed. But 3D printing concrete on the moon using basalt is a very viable proposal, because when you're on the moon, you're going to have to be sustainable. You can't just pop into B&Q for a couple of bags of Portland cement. You're up there and you have whatever is up there, and that's it. And maybe teeny tiny bits of whatever you can afford to fly from Earth. So the technology that I use is totally implementable, and that's very much still in my peripheral. I don't know if I'll live long enough for that. I've lived long enough to work with robots, so I'm happy about that. But I think we're still a few decades away from building anything on the moon. But yeah, ultimately that would be my dream, would be to develop a wonderful circular economy for the moon, and we can start over on a planet and do it right from day one.
Well, they say never. So perhaps in some future year in the podcast, we'll be coming to speak to you about what has appeared on the moon, even if you don't get there personally. Given that our podcast is international and we have listeners from all over the world, Roisin, if you were being able to spread your message to any particular people in other countries, who would you want the listeners to connect you to? How could they help you to spread your message?
Well, my vision for my business ultimately is to work globally. So I think what I can do is I can develop materials where you can make high performance concrete using local byproduct and waste, which I've already done in Northern Ireland. I've done it in Glasgow. I've done it in Iceland. I've done it in North Carolina. I've done it in California. I've done it in Nevada. So basically there's enough waste materials in any geographic location that have the right ingredients to turn into concrete. Like you get it from incinerators, you can get it from mining, you can get it from metallurgy. So there's like byproducts of everything from agriculture that can be used to make concrete. And my idea is that I can formulate these recipes for people and I can share those. I'm looking into using smart contracts on blockchain. So it's an online platform where people will be able to go in. They can put in the materials that they have access to, whether it's waste glass or some steel slag materials or something, and I'll be able to give them the recipe to turn that into concrete. And then they can precast with it if they have access to, like the robot I use is upcycled from a Volkswagen production line. So every couple of years, they have to replace all their robots with the fastest, bestest, with the new features and everything, being in that competitive industry. But the robots that they take out are perfectly good. They've got like 20, 30 years of service left in them. They're really well engineered, very low maintenance. And so people can pick up from the automobile industry a very cheap robot and set themselves up. So what I'm hoping to do, and I'm hoping to do this through partnerships, is demonstrate a remote setup where I will develop the mix and the design for the component, and then I can test it in my lab, and then I can share that through a web platform, and then people anywhere in the world can access that formula and that design, and they can produce components wherever they are. Because over the next, I think, 20, 30 years, urban populations are just going to almost double. We're going to have more, I think it's like up to 90 or something mega cities where you've got over 10 million people. I think in Nigeria, we're actually going to have close to 100 million people living in one city. And at the moment, we're already building an area the size of Manhattan every single day on the planet. And obviously, there's going to be more in developing countries where their cities are only just starting to scale up. So I think it's really important that my technologies reaches people all over the planet, that it's not just focused in the UK or Europe. I think my technology needs to reach global partners. And I mean, it won't be, there'll be lots of people. I feel like robots are like tractors were 100 years ago. When I show people in a lot of different areas working with a robot, I feel like they've come in with the horse and I'm going, this is the tractor, this is how we do it now. So I don't see myself as being the only one doing this. I just feel like I'm one of the first to get, this new technology. And it's actually very straightforward to work with and very easy for people to upskill in a matter of days. And I just feel that it has great potential for creating a more equal society globally, that people will be able to access this technology wherever they are, and we'll be able to share our knowledge, bigger communities, and have more impact in mitigating against climate change and CO2 emissions. We have to do that. It's all about impact and scale.
Well, I think it's really enlightening what you're saying, Roisin, that for a listener, no matter which country in the world they're in, there's a potential in the future for them to be able to take your ideas and make them relevant and useful in their own place.
I've spoken to people already in Papua New Guinea. I've spoken to people in Australia, India, all over South America. People see my TED Talk and they contact me and I reach out to them and we talk and we have a chat. I go, okay, what's within a 50-mile radius of you? What industries are there? I've talked to people, I think, in the Maldives, like the tiny little islands. I'm like, okay, what's in your local waste processing facility? Or what is there? Are there loads of seashells somewhere you can crush up? Is there glass bottles that get recycled? So it applies everywhere. It's a universal strategy.
It's lovely to hear your story today about the impact that you're making on climate solutions, Roisin. So really, it only leaves for me to ask you then, how can people find out more about this? How can they get in touch with you if they want to know more?
I suppose LinkedIn, or I do have a website, a very scrappy website, which I put together evenings and weekends when I'm not cleaning concrete hoses. So that's www.theconcretenomad.com, and LinkedIn is always good.
Fantastic. Well, we'll put links to those on the show notes so that our listener can find out more about what you've been up to and what you plan to be doing in the future, Roisin. I think you've given us a very positive and realistic perspective of the future about what is possible, and yet despite challenges and resistance that any of us as human beings can feel when we face change, that there is a way to move forward so that we can all benefit and manage to create these new solutions for the climate.
Yeah, for sure, definitely.
Thank you so much for your time today, Roisin. It's been great to talk to you. Well, I hope you enjoyed my conversation with Roisin, and she reminded me of another guest we spoke to in episode 93, Andrew Freer, the director of Rural Studio, who talked about the unique architecture programme that they run at Auburn University in Alabama. And here are 2 actions that you can take, having listened to the podcast. First is you can go over to the website, to the reflection section, where we have a list of questions that will help you to reflect on what you've heard in this episode. And secondly, you can sign up for our Zoom listener discussion on the topics that are raised in this series, which will take place on Friday the 21st of July from 1 o'clock till 1:45 BST. And you'll find links to both of those things on the show notes. Next week, my guest will be Professor Dame Anne Glover, who will be talking about the importance of communication in science. And I do hope you can join me then.